going to try solving some basic questions on atomic structure and chemical bondings, and these might help clear all your confusions that you may have regarding this chapter. So without any further delay, let's begin. A radioactive isotope of carbon has more nucleons than the non-radioactive isotope of carbon. How many protons, neutrons, and electrons could there be in this radioactive isotope of carbon? So the isotope of an element has the same number of protons and electrons as the element, but different number of neutrons. And according to the notation in the symbol of carbon, given here, there are 6 protons and the number of electrons is also 6, and there are 6 neutrons, which we will get by subtracting 6 from 12. So the question asks us the number of particles in the isotope, meaning only the number of neutrons would be different and it will be greater than 6. The correct answer here should be option B, because option A here shows all the particles are in equal quantity. Option C shows that there are 6 neutrons, which again is wrong, and so is the number of electrons and protons given here. Option D shows that there are equal number of proton particles in the isotope, which is false again. So we are left with only option B, which shows the correct amount of the particles in the atom. Hydrogen can form both positive hydrogen ions and negative hydrogen ions. Which one of the statement below is correct? So positive hydrogen ions are formed when the hydrogen atom loses the only electron it has in its outermost shell, whereas a negative hydrogen ion is formed when the atom gains one more electron and ends up having a total of 2 electrons. Option A tells us that a positive hydrogen ion has one more proton than the negative ion, which is false, as both the ions have only one proton. Option C tells us that negative ions have one more electron than the positive ions, which again is incorrect. Option D states that the negative hydrogen ion is formed when a hydrogen atom loses an electron, which is false. The only option we are left with is option B, which is absolutely true, and it states that a positive ion of hydrogen has no electron at all in its outermost shell. The table gives the arrangements of electrons in the atoms of 4 different elements. Which element does not form an ionic compound with chlorine? Chlorine is a nonmetal, so in order to avoid the formation of ionic compound, we need to find which one of the elements here is a nonmetal. This would form a covalent bond. In the periodic table, only the groups 1, 2, and 3 have metals, excluding the transitional metals. Also, the number of electrons in the last shell gives us the group elements they are in. So if we look at the options given, only B shows an element belonging in group 4, and so is nonmetal. And this, therefore, is our answer. The diagram shows the arrangement of electrons in a molecule of compound YZ. What are the elements Y and Z? The electrons of Y are represented using the dots, whereas the elements of Z are represented by the crosses. The number of electrons in Y is 6, so it is from group 6, and the number of electrons in Z is 7, and so it belongs to group 7. Option D is the only one that shows the combinations of elements from group 6 and 7 for Y and Z respectively. Therefore, D is our answer. Rubidium is in group 1 and bromine is in group 7 of the periodic table. How is a compound formed between rubidium and bromine? Since rubidium is a metal and it belongs to group 1, and bromine on the other hand is a nonmetal and it belongs to group 7, they are going to form ionic compound where rubidium is going to transfer one of its electrons to bromine, and that is the option D, which will give us our answer, where it states that each atom of bromine receives an electron from an atom of rubidium. The table shows the properties of substances. Which substance is a covalent compound? First of all, a covalent compound does not conduct electricity in any state, be it solid or liquid, whereas an ionic compound can conduct electricity when it is melted or is in liquid state. And so option B shows us the only element where it does not conduct electricity in solid nor in liquid. So option B is our answer. So in this question, we do not need to really much focus on the melting points. We can just simply focus on the electrical conductivity to get our answer. That is all for today's video. Hope you all like it, and please stay tuned for the upcoming videos. Bye bye.